Hello everyone, welcome to our channel, your channel. This is where we bring systematic and detailed solutions to mathematics and physics problems. Now, if you're here to subscribe, make sure you hit the subscription button. Today, we bring you a linear motion problem in physics, a problem that has rattled the internet. Even AIs have found it difficult to solve. Here is the problem. So we expect you to sit tight and enjoy it while it lasts.
In this problem, we have that a bus traveling at 30 meters per second along a straight road passes a stationary cab. Now this cab begins to move 5 seconds later with a uniform acceleration of 2 meters per second squared in the same direction as the bus. Now we are to calculate the time taken by the cab to catch up with the bus, then the distance the cab had traveled to catch up with the bus. To solve this problem, it's a linear motion problem. To solve it, we are going to have to divide the motion into two, talking about the motion of the bus and the motion of the cab. So starting with the motion of the bus, that one is also in two parts. The journey of the bus can be seen to be in two parts. The bus had traveled a certain distance in the first 5 seconds before the cab began to move. Then, when the cab begins to move, the bus had also traveled a certain distance before the cab eventually caught up with it. So dividing the motion into two, or we can start by saying motion of the bus. Now, for the motion of the bus, there are certain representations we are going to make. The first one is representing the time it takes the cab to catch up with the bus in seconds by a certain variable. So we can say, let the time it takes the cab to catch up with the bus be, say, x seconds. We keep that one somewhere. We're going to need it soon. Now, generally, by definition, speed or velocity is distance over time. So we write that as v equals to s over t. V is the speed, s is the distance, and t is the time. Speed in meters per second, the distance in meters, and the time in seconds. So if we cross multiply this, because we're going to be looking for the distance covered by the bus at certain parts, the two parts of the journey. So cross multiplying this will leave us with the distance s to be equal to the product of the speed and the time. Now, like I said earlier on, the journey of the bus is in two parts. But before we go on, we're given the speed or the velocity of the bus. So speed of the bus is given to us as 30 meters per second. Now, let's take part one. Like I have said, the journey of the bus or the motion of the bus is in two parts. So we start with the part one. And this has to do with the distance covered by the bus in 5 seconds. That's the first 5 seconds, the first time given to us. So part one is about the distance covered by the bus in 5 seconds. And to get that, using this equation for the distance, we have that the distance s is the speed, which is 30 meters per second, multiplied by the time, which is 5 seconds. Now, this distance is 150 meters when multiplied. That's the first part of the journey. So we go for the second part of the journey. So the part two is the distance covered by the bus in the time x seconds. That is the time after the 5 seconds during which the cab caught up with it. So part two, journey of the bus in time s, or we can say distance covered by the bus in time x, that is the time it takes the cab to catch up with it. Using this same formula, this distance s is going to be speed. There's nothing in the question that suggested that the speed changes. The speed remains constant. So 30 meters per second multiplied by x seconds. And this is 30x meters. Okay, we may choose to write the meters in full. Now from here, it is important we find the total distance covered by the bus. Now, the total distance traveled by the bus will be the sum of the distances in the two parts earlier calculated. And this is going to be 150 meters plus 30x meters. All in meters, that's the distance covered by the bus. Now, we can make an illustration of the motion of the bus. The illustration will be something that looks like this. This line for the total distance covered by the bus, then it's in two parts. So let's make this portion to be the first part of the journey, while the other one is the second part. So let's put some distance here at the top, while we put time here in this illustration. So the distance covered in the first stage is 150 meters. During the first stage, 150 meters. And during the second stage, that one is 30x meters. Now, how about the timing? The time taken to cover the first phase of the journey of the bus is 5 seconds. So we put 5 seconds here. Then the time taken during the second phase of the journey is x seconds. That is an illustration of the motion of the bus. Now we need to go, while continuing with the question, we need to go for the journey, the motion of the cab. We need to go for the motion of the cab, having obtained the total distance covered by the bus or the motion of the bus. So we have motion of the cab. Now, the motion of the cab is only in one stage, and that is after the 5 seconds that the bus had traveled, then it began to travel and then caught up with the bus at some point. Now, from here, the cab was stationary, and because the cab was stationary, the initial velocity of the cab will be 0 meters per second because it's initially at rest, being stationary. Then, acceleration of the cab is given to us as 2 meters per second squared. The time it takes the cab, in order the cab to catch up with the bus, we have already made a representation for that. That is x seconds rather. So that's all when it comes to the information that we have, the data we have concerning the cab or the motion of the cab. Now, in order to find the distance here, the distance covered by the cab while catching up with the bus, we will need one of the equations of motion based on the data that we have. And this equation of motion that we're going to use is S equals to ut plus half at squared. All the symbols having their usual meanings. So this distance covered by the cab, you can write S cab, is initial velocity is 0, the time is x, the product of those, then plus half times the acceleration, which is 2 meters per second square, multiplying the time, which is x seconds. So this part becomes 0, and this part we have 2 dividing 2, so we're only left with x meters. That is the distance covered by the curve. We may also wish to make a representation or an illustration of the motion of the curve as well. But however, in the case of the curve, the journey is only in one part, just starting and catching up with the bus. And in terms of the distance covered is x meters. Then in terms of the timing, oh sorry, there is a mix-up here. It's supposed to be x squared, t squared, time squared. So the distance is x squared meters. So the distance covered is x squared meters, while the time taken is x meters. Now, with that done, there is a logic behind this motion. Now, the total distance traveled by the bus, that is all the cab had to travel in order to catch up with the bus. Now, this is what I mean. The bus, though, started the journey, but as at the time it passed by the cab, before the cab would start, it had traveled 5 seconds, which actually we calculated to be 150 meters. Then, by the time the cab started its own journey, it continued. There's no record of the bus stopping. So it continued, then it traveled another 30x meters. Now, for this cab to catch up with the bus, it had to travel this total distance, the 150 meters and the 30x meters. So which means the total distance traveled by the cab, x squared meters, must be the same thing as the distance traveled by the bus, and that forms the basis for how to calculate the value of x, which is the time taken by the cab to catch up with the bus. So we equate the two of them in order to solve for x. That is, x squared must be equal to 150 plus 30x. Now this leaves us with a quadratic equation, so we can rearrange to have x squared minus 30x minus 150 will be equal to 0. Now this does not factorize, so we use the quadratic formula. Now using x equals to negative b plus or minus square root of b squared minus 4ac over 2a, which is a quadratic formula, where a from this equation is the coefficient of the x squared, and that's 1. B is the coefficient of the x, negative 30, and c is the coefficient, the constant term, which is negative 150. So substituting these values into the formula, we have that x equals to minus negative 30 plus or minus square root of negative 30 squared minus 4 times a, which is 1, times c, which is negative 150 over 2 times 1. That's 2a. And that is going to be negative times negative 30 minus times minus 30 gives a positive result, which is 30, and plus or minus square root of negative 30 squared becomes a positive 900. Now negative times negative here becomes plus or positive, and 4 times 150 is 1 600. Then that divided by 2. Now, taking it up from here, we have it to be 30 plus or minus 1,500, that's the sum of 900 and 600 divided by 2. Now, this 1,500, the square root of 1,500 can be written according to the laws of rational numbers. We can have it as the square root of 100 times 15, and the square root of 100 is 10. So that becomes 10 root 15. So we can use that to simplify it in the expression to give us 30 plus or minus 10 root 15 divided by 2. And with that done, we can actually factor out 2 in order to divide the 2 that we have in the denominator. So if we factor out 2, we are going to have 15 from here, then plus or minus 5 root 5, then divided by 2, so that these 2 can go off, and then this is 15 plus or minus 5 root 5. Then we can separate the plus or minus, and that gives us 15 minus 5 root 5. Then for the value of x, or x could be 15 plus 5 root 15 rather. 5 root 15. Now, looking at the first value, the square root of 15 is more than 3. It is more than 3. So if we multiply 5 by 3 points, the square root of 15 is about 3.8 something. It's about 3.873 to 4 significant figures. So if you multiply 5 by that, the answer is going to be way more than 15. And if you subtract it from 15, we're going to have a negative result. So this value is not possible because time is never negative. So this one is inadmissible. We can't admit it, which means we are left with this positive value. So we can say x is 15 plus 5 root 15 in seconds. So we can now conclude by saying that the time taken by the cab to catch up with the bus is 15 plus 5 root 15 seconds. Now, we may not want to have our answer in rational form. We may want to have it as a decimal fraction. So the square root of 15 is about 3.873 multiplied by 5, and then adding 15 will give us something around 34.365 seconds, or 34.4 seconds to 3 significant figures. Now, that is part 1 of the question. The second part of the question asks us to find the distance traveled by the cab in order to catch up with the bus. So to find this distance in the second part, we can make use of any of the expressions, the equations that we already have. So the distance traveled by the bus to catch up with the cab, is, according to our previous calculations, we got 150 plus 30x, or we also got x squared. So any of the two will give us the same result. Now let's try to use x squared. That can be faster, which is starting with the root 15 plus 5 root 15 squared in meters. And that, when we expand this, is going to be 225 for 15 squared, plus 2 times 15 is 30, times this 100 and plus 150 root 15, and plus, when we square this one, square of 5 is 25, and square of the square root of 15 is 15. So we've got 25 times 15. 25 times 15 is 375. So when we add 375 to 225, it gives us 600, then plus 150 root 15 in meters. That would be the value, but we may not want to stop here. We may want to go for the decimal answer, the decimal number. So this is going to be 600 plus 150 multiplying 3.873, which is the square root of 15. And that is going to give us 600 plus, when we multiply these two, 580.95 that we get. So that is around 1,180.95 meters. And this can, to three significant figures, be approximated to 1,180 meters. So this is the distance that the cab had to travel in order to catch up with the bus. I believe you enjoy the step-by-step taking solution to this problem. This problem, don't forget, like we said earlier on, has been something that's given physicians some challenge in solving it. There have been so many wrong answers flying around, but here is the solution. Don't forget to leave your comments in the section below, or you can send it to us in the email, the email handle, which is also attached or given in the description. Make sure you help us share the page, help us share the video and our other videos. We do mathematics and physics. Share with people, subscribe so that you can get the latest updates from us. Thank you.